Hi guys, let's talk about extraneous roots. Let's say we are given this algebraic equation, x squared plus x plus 1 equals 0. This is a quadratic equation, so we let x to be not equal to 0. Because if x is 0, then what's left is 1 equals 0, which is definitely an incorrect equation. Then, let's divide each of the terms of our given quadratic equation by x to arrive at this next line. And then simplifying, x squared over x is equal to x over x is 1, and 1 over x is copied, the right side is equal to 0. This is a valid operation because x is not 0, so we are not dividing by 0 here. And then, notice that from the given equation, if we subtract x squared from both sides, we arrive at x plus 1 equals negative x squared. And substituting now this value for x plus 1 in this result, we replace this x plus 1 by x squared, and we just copy 1 over x, copy equals 0. So basically, we substituted negative x squared for x plus 1 in the previous step. And then let's simplify this further by adding x squared to both sides of the equation to arrive at this. So we have 1 over x equals x squared. We accomplish this by adding x squared to both sides of this equation. And then multiplying both sides of this resulting equation by x, we arrive at 1 equals x cubed. And getting the cube root of both sides of the equation, and we arrive at 1 equals x. And then let's substitute this 1 to the original equation. So here's our original equation, and replace all the x's by 1, we arrive at 3 equals 0. What's the problem? Why is 3 equals 0 here? Now let's number our equations from 1 to 6. So which step here is erroneous? You can pause the video and write in our comment section where is the error in these algebraic steps. Now let's solve this problem together. The error happens between steps 2 and 3. So let's look at these two steps. From step number 2 to arrive at step number 3, we introduce what we call as an extraneous root. An extraneous root seems to be a solution to an equation, but when we substitute that result to the original equation, we arrive at an error. So this is just an extra root. And that happens when we multiply both sides of an equation by expressions containing variables or by raising both sides of an equation to powers. In order to jump from step number 2 to step number 3, what happens is we multiply both sides of the equation in step number 2 by the quantity 1 minus x. Notice that if I multiply the quantity 1 minus x times the quantity x plus 1 over x, here's the computation. We multiply each of the terms of the binomial to each of the terms of the trinomial, pair by pair. The results are these yellow expressions. But notice that x minus x is 0, 1 minus 1 is 0. What's left is negative x squared plus 1 over x, which is what we have here in step number 3. And at the right side here, the quantity 1 minus x times 0 is 0. So this third step now happens because we multiply both sides of the equation by 1 minus x. And by multiplying both sides of the equation in step number 2 by the quantity 1 minus x, we introduce an extra root. And that extra root is now computed this way. You have here product resulting to 0, which means that any of these factors could be equal to 0. So if 1 minus x equals 0, the root is x equals 1. And if you have x plus 1 over x equals 0, the roots are negative 1 plus or minus I squared of 3 all over 2. Now, this part here is equivalent to this original equation, and this has two roots, which are these ones. And the extra root is x equals 1. That happens when we multiply both sides of the equation by the quantity 1 minus x. So going back now to the original equation, this x equals 1 that we computed in step number 6 is that extraneous root. And so when we substituted 1 for x in the original equation, we arrive at 3 equals 0, which is obviously wrong. And so our conclusion is this x equals 1 is an extraneous root. And so we have just proven that 3 is not really equal to 0. What happens here is we are just checking whether the roots that we arrive at is really a valid root for the original equation. And so here is our recommended video for your next viewing. This is Rolando Asisten, and we hope to see you again in our next video. Bye for now.